Welcome back to Technically You. Today we're exploring network queuing methods, a crucial concept for managing data flow and ensuring network performance.
That's right. Without queuing methods, networks would struggle to deliver data efficiently, especially during high traffic periods. We're going to break down what queuing methods are, what they provide, and explore the key types, including FIFO, WFQ, CBWFQ, PQs, CQ, WRR, LLQ, and RED. Let's get started.
So let's begin with the basics. What are network queuing methods?
Network queuing methods are techniques used by routers and switches to manage how data packets are stored, prioritized, and transmitted.
Essentially, when multiple data packets arrive at a router or switch, queuing methods determine the order in which those packets are sent out.
Exactly. These methods help prevent congestion by organizing packets efficiently, ensure fair bandwidth allocation among different applications, and prioritize critical traffic like voice and video for real-time performance.
So queuing methods are essential for ensuring that important data gets through without delay while still handling other network traffic.
Let's explore the main types of network queuing methods, starting with the simplest one, FIFO.
FIFO stands for first in, first out. This method is straightforward. The first packet to arrive is the first to be transmitted.
Imagine a checkout line at a store. The first person in line gets served first. Similarly, packets are processed in the order they arrive, without any prioritization.
While FIFO is simple and efficient for low-traffic networks, it doesn't prioritize critical data, which can be a problem during congestion.
Next up is WFQ, or weighted fair queuing. This method is more sophisticated because it assigns weights to different types of traffic.
Right. Packets with higher priority or smaller sizes get transmitted first, ensuring that critical applications like voice and video receive the bandwidth they need.
Think of WFQ as a fast pass lane at an amusement park. Important or time-sensitive packets get to skip ahead of less urgent traffic.
Now, let's talk about CBWFQ, class-based weighted fair queuing. This method is an enhancement of WFQ, allowing network administrators to create classes of traffic with specific bandwidth allocations.
For example, you might reserve 50% of your bandwidth for video conferencing, 30% for web browsing, and 20% for file downloads. Each class is guaranteed a certain amount of bandwidth, ensuring consistent performance.
CBWFQ is great for organizations that need to ensure specific applications always have enough bandwidth, even during network congestion.
Next, we have PQ, or priority queuing. This method prioritizes packets based on 4 priority levels: high, medium, normal, and low.
Packets in the high priority queue are always sent first. Only when that queue is empty does the router process packets from the lower priority queues.
This ensures that critical data, like voice and video, is transmitted without delay. However, if high priority traffic is constant, lower priority packets may experience delays or even get dropped.
Moving on to CQ, or custom queuing. This method allows administrators to manually configure the number of packets each traffic type can send during a cycle.
Imagine dividing a pizza into slices. Each application gets a specific slice of bandwidth. This ensures that no single application consumes all the bandwidth.
CQ is particularly useful when you need to ensure a minimum level of service for each type of traffic, even during high demand periods.
Next is WRR, or weighted round robin. This method works by cycling through different queues, but it assigns weights to each queue based on priority.
For example, a high priority queue might get to send 3 packets each cycle, while a low priority queue only sends 1 packet. This ensures that high priority traffic gets more bandwidth without completely starving lower priority traffic.
WRR is great for balancing efficiency and fairness, especially in networks with mixed traffic types.
Now let's talk about LLQ, or low latency queuing. This method is specifically designed for real-time traffic like voice and video.
LLQ combines the benefits of PQ and CBWFQ. It provides a dedicated priority queue for real-time traffic, ensuring that voice and video packets are transmitted immediately with minimal delay.
Unlike standard PQ, LLQ prevents lower priority traffic from being completely starved. making it ideal for VoIP and video conferencing.
Lastly, we have RED, or Weighted Random Early Detection. This method is unique because it proactively prevents congestion by randomly dropping packets before the network becomes overloaded.
Right. By dropping lower priority packets when traffic increases, RED helps maintain consistent performance for high priority traffic.
Think of RED as a safety valve that prevents the network from reaching its breaking point.
Let's quickly summarize the key differences between these queuing methods. FIFO, simple, first come, first served. WFQ, prioritizes packets by weight and size. CBWFQ, guarantees bandwidth for specific traffic classes. CB, always sends high priority packets first. CQ, always sends bandwidth manually for each application. WRR, cycles through queues with weighted priorities. LLQ, provides a dedicated queue for real-time traffic. RED, prevents congestion by dropping low-priority packets early.
These queuing methods are essential in modern networks, especially for enterprises, ensuring reliable performance for critical business applications. ISPs, managing bandwidth for millions of users. VoIP and video services, reducing latency and jitter for real-time communication.
Choosing the right queuing method depends on the specific needs of your network, the type of traffic you're handling, and your performance goals.
So there you have it. Network queuing methods play a vital role in managing data flow, preventing congestion, and ensuring that critical applications perform smoothly.
From simple methods like FIFO to advanced techniques like LLQ and RED, each method has its strengths and use cases.
And thanks for tuning in to Technically You. Don't forget to like, subscribe, and leave a comment if you have any questions or topics you'd like us to cover next.
Until next time, remember to always stay curious.